there's been a crime and there's an unknown powdery substance left at the crime scene, and it's up to me to find out what that powdery substance is. It could possibly have carbon, hydrogen, oxygen, and nitrogen in it. When combusted with, it was a 0.5 gram sample, and when combusted with O2, it produced carbon dioxide and hydrogen, H2O, and there are no grams of nitrogen. But these are what's left of carbon dioxide, 0.8912 grams, and H2O, 0.3649 grams. The total molar mass is about 222 grams per mole. Let's get to it. First, I take my carbon dioxide, my grams of carbon dioxide, and convert it to moles of carbon. In order to do that, I have to find the molar mass of carbon dioxide, which is 44.01 grams, equal to 1 mole carbon dioxide, and the mole-to-mole ratio is 1 mole of CO2 to 1 mole of carbon, which gets me 0.0205 moles of carbon. My mass of H2O is 0.3649 grams, divided by the molar mass of H2O, multiplied by the molar ratio of H2O to hydrogen, which is what I'm trying to get by itself, is 2 to 1. So, grams of H2O divided by the molar mass of H2O multiplied by 2 to get 0.0405 moles of hydrogen. Now I need to convert moles of carbon and moles of hydrogen into grams in order to find my grams of oxygen. 0.0205 moles of carbon times the molar mass of carbon equals 0.2462 grams of carbon. After, eliminating that. And then for hydrogen, same thing, 0.0405 moles of hydrogen multiplied by the molar mass of hydrogen equals 0.04082 grams of hydrogen. Subtract those amounts from the sample will give me oxygen, which is 0.21298 grams of oxygen. I need to convert this to moles to find out which carbon, hydrogen, or oxygen has the fewest moles, and then I can divide by that. So to convert grams of oxygen into moles, I divide grams of oxygen by the molar mass of oxygen to give me 0.01331 moles of oxygen, which happens to be the smallest amount, so I can divide moles of hydrogen and moles of carbon by moles of oxygen. After dividing these three numbers, I come up with about 1.5 for carbon, about 3 for hydrogen, and of course 1 for oxygen. But that's not a small whole number, so I have to multiply that by 2. And that gives me the empirical formula, which then gives me C3H6O2, which is, after doing an internet search, called hydroxyacetone. Now, this is where I got confused because I don't believe this is a powdery substance, although it could, this substance could come out of the powder, I suppose, after combusting with CO2. Nevertheless, to double check my work, I found the molar mass of C3H6O2, and that's only 74 grams. So I'm not sure why I'm not getting 222 grams per mole. That's what's confusing me. And this should not be just grams, it should be grams per mole. So this is my first attempt. I may not get full credit for it, but I can probably try. I will probably try again. But that's it for this question.